Every single day, you press the same keys in the same positions that a mechanical engineer arranged over 150 years ago. You have never questioned it. Neither has almost anyone else. And that, in itself, is one of the most revealing things that can be said about how technology actually spreads through human civilization. Before the typewriter became a fixture of offices and newsrooms, written communication moved at the speed of a human hand. Clerks copied documents letter by letter. Business correspondence piled up in backlogs. Courts, banks, newspapers, and government offices all ran on handwriting. And handwriting had a hard ceiling on speed and legibility. The promise of a mechanical writing device was enormous. Consistent letter forms, greater speed, and documents that anyone could read regardless of who produced them. The design that became commercially significant arrived in 1874. The keyboard layout it introduced is now known as QWERTY, named for the first 6 letters on the top alphabetical row. According to documented history, this layout was not handed down from a single moment of brilliant engineering. The original design intentions, as the historical record makes clear, remain genuinely unclear. What is known is that the layout became standard, was carried forward by manufacturers, and eventually migrated from mechanical typewriters to electric ones, then to computer terminals, and finally to every smartphone and laptop on the planet. That migration is not a story of the best design winning. It is a story of a constraint becoming a convention, and a convention becoming so deeply embedded that alternatives struggled to gain any foothold at all. The mechanical typewriter operated under physical limits that a digital keyboard does not. The typebars, the small metal arms carrying individual characters, had to swing upward and strike a ribbon without colliding with each other. If a typist moved too quickly between certain letter combinations, the bars would jam together and the machine would lock. Early operators and manufacturers both had to deal with this problem constantly. The arrangement of keys on the keyboard was, at least in part, a response to that mechanical reality. Whether QWERTY solved the jamming problem optimally or only partially, or whether it was shaped by other factors entirely, is something historians have debated. What is not disputed is that the mechanical jam was a real constraint, and that the layout emerged in an era when that constraint was the dominant engineering challenge. The typewriter keyboard became the standard keyboard. That sentence sounds obvious, but its implications took decades to fully arrive. When manufacturers settled on a common layout, they created a training economy. Typing schools taught one layout. Businesses hired typists trained on one layout. Office managers bought machines compatible with one layout. Each of those decisions reinforced every other decision in a self-reinforcing loop. By the time anyone seriously proposed a different arrangement, that loop had been running for over half a century. In 1936, August Dvorak and his brother-in-law William Dealey patented an alternative keyboard layout. The Dvorak layout was designed with a different goal in mind: reducing the total distance fingers travel when typing English, placing the most common letters on the home row, and distributing the workload more evenly between the two hands. Proponents of the Dvorak layout have argued that it requires less finger motion, reduces errors, and may lower the risk of repetitive strain. Those are genuinely held claims, and they have attracted committed advocates over the decades since the patent was filed. What the Dvorak layout ran into was not a technical problem. Its challenge was a social and economic one. Retraining typists cost time and money. Replacing machines cost more. Businesses that had already invested in QWERTY-trained workforces had no practical incentive to absorb those costs, even if the long-term efficiency gains were real. And the long-term efficiency gains were themselves disputed. studies comparing the two layouts have produced conflicting results, and researchers have pointed out that many of the early studies favorable to Dvorak were conducted or influenced by August Dvorak himself, introducing questions about their objectivity. This is where the story becomes genuinely complicated, and where honest narration requires separating what is established from what is contested. It is an established fact that QWERTY became and remains the dominant layout for English-language keyboards. It is an established fact that the Dvorak layout was patented in 1936 and has attracted advocates who report real benefits. What remains unresolved is whether, under neutral testing conditions, Dvorak provides a meaningful and reproducible speed or ergonomic advantage over QWERTY for the average trained user. That question has not been definitively settled, and anyone who tells you it has in either direction is moving ahead of the evidence. What the computer age added to this story was not a resolution. It was an acceleration of the same pattern. When IBM introduced the PC keyboard, including the influential Model M introduced in 1984, the layout it used was the same layout that mechanical typewriters had carried into offices a century earlier. Computer keyboards, as the record shows, were explicitly modeled after typewriter keyboards. The physical constraint that originally shaped the arrangement, the jamming typebars, was completely gone. The digital keyboard has no typebars at all. There is no mechanical reason in a digital device why any particular letter must sit in any particular position. And yet, the positions stayed exactly where they were. This is what makes the QWERTY story genuinely instructive rather than simply ironic. The constraint that produced the layout disappeared. The layout did not. It persisted because enough people had learned it, enough devices used it, and the cost of switching exceeded the perceived benefit of switching. Economists call this dynamic path dependence. The path you are on shapes where you can go, not because the path is the best route, but because the infrastructure, the habits, and the training that built up along that path make departure expensive. You can see the same dynamic at work in other contexts entirely. Keyboard layouts are a visible and approachable example of a much broader phenomenon in which early technical decisions, made under constraints that no longer exist, persist long after those constraints have vanished. The electrical grid, the dimensions of rail gauges, and the side of the road that different countries drive on, all carry traces of choices made under conditions that are now historical. QWERTY is simply one of the cases where you interact with that legacy personally several hundred times a day. It is also worth noting that the story did not end in the English-speaking world. The challenge of adapting keyboard layouts to different writing systems produced entirely separate histories. A prototype typewriter keyboard for the Khmer script was developed as late as 1947, illustrating that the problem of matching a mechanical layout to a language's actual structure was not unique to English, and that different constraints produced different responses in different places. Today, QWERTY is the default layout on virtually every English-language computing device sold anywhere in the world. Alternative layouts remain available as software options on most operating systems, requiring no hardware change and no additional cost. The technical barrier to switching has essentially been eliminated, and still, the overwhelming majority of users never switch. That is not a story about inertia in the pejorative sense. It is a story about the real costs embedded in learned behavior. Relearning a keyboard layout as an adult is genuinely difficult and temporarily disruptive to productivity. The people who make that transition report a period of significant slowdown before any potential benefit arrives. For most people, that trade is not worth making, particularly when the expected gain remains uncertain. So the lesson the QWERTY keyboard actually teaches is not that we are irrational, or that bad designs always win, or that engineers failed us. The lesson is more precise and more useful than any of those framings. A design shaped by a specific physical constraint can outlast that constraint entirely if it becomes embedded in human skill, institutional practice, and interconnected infrastructure before a better alternative is ready to compete. The window during which a new design can displace an established one is narrow, and it closes faster than most people expect. The next time you look down at your keyboard, you are looking at the archaeology of a problem that no longer exists, preserved in plastic and habit. And the question that follows naturally from that is not about keyboards at all. It is about what other arrangements in your daily life are still shaped by constraints that quietly disappeared decades ago, leaving only their footprint behind. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.